Speaking English.
Don't go there. Okay. So, don't be doing this.
For a new lesson?
Yep, new lesson. So what's our situation with functions? Well, we've done the different types of mappings. One, one, many, one, and many. We've also done functions, one-to-one and many-to-one. We've also done onto. We've also done composing functions, remember composing functions, and domain and range. So, this is all really building up to this lesson now, which is called finding the inverse of a function. So if you think for a moment, here is domain, and then here is codomain. So we know a function takes something from the domain and gives you something in the codomain. So that would be f of x. So let's say here we start with x and here we finish with y. The question now is, can I go backwards? Can I find a function that takes the y and gives me back the original x? So this would be called f inverse y. In other words, a function that undoes what you just did, or undo operation, I suppose you could say. So I give us a simple example where it's clear. If you have the function f of x equals x plus 1, this takes x and adds 1 to it. So if you want to undo that, then the function that does that will be this one, f of x equals x minus 1. Okay, so this function here would undo what you did previously. So for example, f of 2, what would that equal? 3. And then what would f inverse of 3 equal? 2. 3 minus 1, yeah? No, please, you can't be looking confused yet. Confusion can be later in the class, not now. Yes?
F inverse y or f inverse x?
The latter is not actually important. I usually use y, but I taught the students to use y last year, and the University of Manchester said in the answer books that they prefer the students to use x. It actually doesn't make any difference, you know. You could say fx equals x squared. That is exactly the same as saying ft equals t squared. The latter is not important. The latter is just a way to describe what the function does. What does the function do in this case? In this one here? It squares, doesn't it? So the latter is of no importance unless you're in University of Manchester where you want a particular letter. Who knows why? So I will try to do what they asked and stick to just using x in my function definitions. But if somebody wants to go crazy and use a t, I won't stop you.
No.
I won't stop you, okay?
If it is fx equals x plus 1, that means it should be f inverse of x, not f inverse y.
Yeah, if I put a y here, then it would be y minus 1. And if you wanted to go nuts and put a t here, then it would be t minus 1. It's up to you. It's up to you. Okay, so let's try and get this a little bit more pinned down for the definition. Joseph, come on. So let's try and get this a little bit pinned down more for the definition. If you think about back in semester 1 matrix, we said matrix A is an inverse of A if A multiply A inverse equals, does anybody remember? Not 1, not 0. Pi, thank you. Yes. So you get something similar with functions. Does anybody have any idea what would be the function that's like the identity? What I mean is, in matrices, what do you multiply a matrix by if you don't want it to change? 1, 0, 0, 1.
Oh, matrices.
Yeah, matrices. And if you want to just have a regular x, what do you multiply x by so that it doesn't change? 1. Does anybody have any ideas what might be an equivalent idea for functions? The function that doesn't cause any change. So if I call this function I, like identity, what do you think this function is?
There will be no x's.
No? Very good. You're on the ball today, Ahmed. I'm telling you. So this here is the identity function, and it doesn't do anything. You know? So like I of 2 is 2, I of 3 is 3, I of 4 is 4. It does nothing. It's the identity function. It takes x and gives you x. And that's it. Okay? So, with this in mind, this gives us a technical definition of what the inverse is. If you have f and you compose it with f inverse, what do you think the result should be? It should be I. This is a lot like matrices, isn't it? What does A multiply A inverse equal? I. And what does x multiply x inverse equal? 1. This is just normal x, okay? Just a regular number. Yes? I'm trying to get you to appreciate the similarities between this definition, and this definition. Yes? No, you just satisfy and, yes. Similarities appreciated? Much appreciated. Okay, yes?
Saying I is the same as saying 1?
No, I is a very special function. It's the function that doesn't do anything. So like, for example, I of 2 is equal to 2. I of 3 is equal to 3. Or in other words, if you really don't want to think about it like this, you can think of the I function, it just multiplies the number by 1. Or another way to think about it is by it adds 0.
I just don't understand how x times x inverse equals 1 and a times b.
Here, well, this is just normal algebra.
No, but how is that equals to 1 and that one equals to I?
But these aren't numbers, these are functions. Like, for example, a number by a number is a number, right? You don't make a number by a number equals lunch. No. Number by number is number. Matrix by matrix, matrix. So a function with a function should also be a function. So it is not, although some people might write the number 1 here, and I have seen that, and that's not a big deal if you want to write the number 1 here. It's not entirely accurate because you should have a function here since you have 2 functions here. You know, you need to keep the nature the same. Like in physics and chemistry, you know, a meter plus a meter makes another meter. You know, you can't be mixing types. So a function and a function together should have a function on the other side. Okay? Matrix, 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 number, number, and number. Okay? So I'll give you an example with this definition. I will use this definition to show what we already know, that this is an inverse of that. So we'll have a look now. I can scroll down here, example. So fx equals x plus 1, and f inverse x equals x minus 1. So let's compose them together. F inverse x, that equals f of f inverse. And what's f inverse here? X minus 1. That's minus 1 there. And if I put this inside of the f function here, what do I get? X minus 1 plus 1, which equals x. And what is the function that is just x known as? This is just the identity function. Yeah, the plain old does nothing function. Identity function here. So that's how you can prove something is an inverse. So if the question said, show that this is an inverse of that, this is what you do. You compose the function with its inverse, and the result should always be x. That's coming from the fx, because the x minus 1 went into the f. See here? Yeah? Yes?
The fx and the fx, the f inverse x can change, right? They're not always x plus 1.
No, this is just my example. I'll do another one now. Let's see. Okay, can I go down? Or do you need to write this? Another example? Okay, yes?
Is this related to the lessons you took on Monday?
So far, no. No, not yet. Well, no, actually, did we do composing functions on Monday?
Yeah.
Did we? So then, yes, it is. Okay, let's take fx equals 2x plus 1. And then f inverse x equals x minus 1 over 2. Now, this isn't a proof, but let's just check for ourselves to see that it's true. So what does f of 2 equal? 5. And what does f inverse of 5 equal? 2. Which is back at the start, isn't it? So your 2 has gone to 5, and then when I do the f inverse, it's gone back to 2. You don't need to write that down, but this just should give you confidence that it is probably the inverse. But that's not a proof, of course. So if I said now, show that f and f inverse here are actually the inverse. Well, we start off with our definition, f inverse of x. And by the way, you can swap these around if you want. It doesn't matter. You can have the f inverse outside and the f on the inside. Okay, so we have f and the inverse on the inside here. Now, if I put this function here into the f, I will get 2 times x minus 1 over 2 plus 1. So what happens here? 2's cancel. X minus 1 plus 1?
Yes.
Yeah. Is x, and what is x? That is just the identity function. So again, we've shown that it is genuinely the inverse. Yes?
It has to be x. Okay.
Has to be x for it to be an actual genuine inverse.
What do you mean with the ix?
I am making it very explicit to the reader that I've put my f and f inverse together and have made an identity. Similar to in matrices, if you multiply A and A inverse, you should get the identity matrix. So I don't really have to do this, but it makes it very, very, very clear to the reader that you're saying you got the identity at the end, which is what you want for an inverse and the original. Yes, it is recording. Okay, that's great. Well, no, you won't think that's great. That's fine. So now, how do we calculate the inverse function? So I give you a function and I say, tell me what the inverse is. Like with matrices, you have a formula. You don't have a formula with functions, but you have a procedure, and this is the procedure. So let us take this one as an example. So I tell you f of x equals, what was it, 2x plus 1, and I want the inverse here. What do you do? Well, the process is as follows. You start off a bit like with domain and range. You say y equals 2x plus 1. And then what you do is you rewrite it so that instead of having y equals, you have x equals. So I'll take the 1 to the left. I get y minus 1 equals 2x. And then what should I do next? Divide by 2. So I get y minus 1 over 2 is equal to x. And you are done, practically. In the past, I would say f inverse y equals y minus 1 over 2, but I don't know why they don't like this in the exam, so you want to write your answer like this. F inverse x equals x minus 1 over 2. Like that. So that's the inverse function.
What's the name?
Huh?
The name of the
Have a guess. Go on, have a wild guess.
Inverse
Mm-hmm.
function.
Yep, you got it. Okay, do you need to write this down?
Yeah. Name was the last.
No. He wanted to know the name of the lesson. I think I need to come up with a better name, though, now than inverse of a function.
Because it's obvious.
The inverse of a function and the return of the phantom menace, or maybe something. Inverse of a function, A New Hope, maybe. Okay. Can I do another example, one that's a little bit more difficult than this? Okay, so one now with an E in it. So let's say, yes.
Why did you change the y into x?
Oh, come on, I've said it a few times now. Can somebody tell her why?
It doesn't matter about the number at the same.
Yes, and
Manchester.
yes, thank you. All right, another example now. Y equals e to the 4x plus 1. And you want the, fx equals. And you want the inverse function here. So like before, you start off with y equals e to the 4x. I'll write this down further. Y equals e to the 4x plus 1. So if I want to get the x here, what do you think I do first? Log. So log y equals 4x plus 1. What's next? Bring 1 to the other side and then divide by 4. And that's equal to x. So there you go. The inverse is equal to log x minus 1 all over 4. So now that we know what the inverse is, and now we know how to find the inverse, the question is, can you always find the inverse, or is it always right to find the inverse? We know from matrices that finding an inverse is not always possible. Think back to semester 1, for example. When can you not find inverse of a matrix? What's the condition? When the determinant AD minus BC is 0. Likewise, you have something for functions as well. You can't always find the inverse. Does anybody know or have an idea when it wouldn't be appropriate to find the inverse, or where it wouldn't work, or it doesn't make sense? Not x equals 0. That is a good standard maths answer for when there's a problem when x is 0, yes, but not in this case, no. Anything else? Well, think about this. What does the inverse do? The function goes from domain to codomain, and the inverse takes you back to the original. Not minus 1, I don't know. So when could there be a problem? Well, let me show you when there could be a problem. So let's say I say fx equals x squared. What is f of minus 2? 4. And what would be the inverse? Well, the inverse is square root, isn't it? So what is the square root of 4? But you can't use plus or minus because functions have to have only one value. They need to be well defined. They need to be 1, 1.
So,
Or-
square root of the absolute value of x.
So in other words, 2, right? Like the square root of 4 is 2. Yes. Have I gotten back to the original? No, because I started with 2 and the f took me to 4 and the minus 2. The f took me to 4 and the f inverse took me to 2. I am not back where I started. Why did it go wrong here? What is so special or not special about this function?
Does it have like an x?
I'm not hearing the key word here.
Two possible.
Yes, 2 possible values, so it's what all the vocabulary you did today.
It's It's many to one.
It's not, yes.
It's not one to
F is not one-to-one. And this is what's preventing the inverse being found here. When it's one-to-one, it takes one value to one value. And so it is easy to go back. If it's not one-to-one, it means it takes one value to one value, but it might take something else to the same value, and you have no idea how to go back. So in this example here, this is how, or this is an example of how not being one-to-one is a problem. So if something is not one-to-one, what do we call it? In this case, it's many-to-one. So you can only find the inverse if it is one-to-one. And if it's many-to-one, it has no inverse. So I'll write that down as a rule, sorry. So F has an inverse. That means F is 1-to-1. And F has no inverse. That means F is likely many-to-one. So if a question asks you does this function have an inverse, that is just another way of really asking you, is this function one-to-one or is it many-to-one? So, let me give, I still have more examples to do, but I want you to have a look at number 1 for what I'm about to say next. Can you look at number 1? So, in part A, would you say the function in 1A is invertible? That means, would you say the function in 1A has an inverse? So, does the function in 1A have an inverse? Yes or no? Yes. 1B? No. 1C? Maybe, probably not though, but maybe. G?
No. Yes.
Yes, it does.
Yes.
E?
No. Yeah.
No, I wouldn't say E has an inverse. D might, or D does, E wouldn't. What about F?
Yes.
F does, yeah. G?
No.
Yes. H?
No.
No. I?
Yes.
Yes. Now it gets a bit tricky. What about K?
No. No. Yes.
What do we think? Do we think this is 1-to-1?
Well, can we cancel it out?
It's many to one.
Like, we split the functions. Like, if we expanded the brackets, we should if there was a single value that was.
Yeah, what you would have to do for K is to find out if it has an inverse. You need to find out if it's 1-to-1. And to find out if it's 1-to-1, you need to do that trick. Fx1 equals Fx2. No, don't shake your head. That's not a question. If you have a question, please ask me a question. Do you remember in like the last lesson, wasn't it? I said to check if something is 1-to-1 or many-to-1, you have to check if Fx1 equals Fx2. This was the last lesson, right? And some of you did that this morning, right? Yes. So you can check using that formula if it is 1-to-1 or many-to-1. If it is 1-to-1, it will have an inverse. If it is not 1-to-1, it will not have an inverse. I think it's probably not going to have an inverse. Okay. What about L?
Yes.
Has.
I think it probably does. M? No, because it's not 1-to-1. Because what happens? It repeats. It repeats. And so on, and so on. By the way, there's the same typo in this worksheet. My X have fallen off the quadratics. You know, it should be like, for example, in question E, x squared minus 1x minus 12. The x's have slipped. Okay, so 1 is more to do with the last lesson. Number 2 now is my next example. So I'll look at 2a here. So, look up here, Brendan. Who are you sitting beside who's causing you so much trouble? Sadiq? No one causing you trouble? Alright. Sadiq, you causing trouble?
I didn't see anything.
Good, okay, alright. Is this function 1 to 1 or many to 1? Many to 1. So does it have an inverse? No. But if you make the domain small enough, you can make it 1 to 1. What is the problem here that's not making it 1 to 1? What's the big problem here? The square, which means if you put in a positive number or a negative number, you get the same answer. So how could you prevent that problem from happening? Well, you could not allow people to put in negative numbers. So for example, if I said domain is equal to 0 infinity, now is it possible to have two different x values but the same y value? If possible, give me the two x values that make the same value here. Quick check. What's f0? Come on, quick. Minus 4. What's f1? Minus 3. F2? No. 0. F3? 5. As you go through this list, will you ever see the same number again? So I've made it 1 to 1 now, and I've made it 1 to 1 by restricting my domain. Now I'm seeing some confused looks, more confused looks than accepting looks. So if you have questions, please ask me so I can explain the problems away.
How do you write it out other than just
No, the only reason I wrote those numbers there was to try and convince you that it's now 1 to 1. You don't have to write them down. That's just to convince you. Suppose I said instead, don't write this down, domain is minus 1 to infinity. Is it 1 to 1 or many to 1? Many to 1, because f of 1 and f of minus 1 will be the same value. What's f of 1? Minus 3. F of 1 is minus 3. And what's f of minus 1? Also minus 3, okay? So what I'm telling you now is that a function that is many to 1, you can make it 1 to 1 if you choose the right domain. But somebody here maybe has spotted a second answer I could have used for the domain.
0 to minus infinity?
Yes, you could have done it the other way around. You could have said minus infinity to 0. And this answer would also make it 1 to 1. So in fact you have two answers here. Now the next question is, how do you find this though? So I'll show you now in a minute. Okay, so let's have a look at one not quite as easy as that. So if I do 2b, I say f of x equals, okay, x cubed plus 6x squared plus 8x, I think. All right. Now this one here is not going to be 1 to 1. It's going to be many to 1. And if I just draw a very rough graph of it, looks something, I don't know, roughly like this. So you can see that it's not 1 to 1 because its height changes several times and repeats some of the heights. But if you want to make it 1 to 1, all you need to do is choose a domain that causes the function not to repeat itself in height. So for example, this part here by itself is okay, because is the height ever the same in this part? No. The height never repeats itself in this yellow part here. The height is getting smaller, the height is getting bigger and bigger and bigger and bigger. You could look at this piece here, or you could look at this piece here. So if you were to, for example, say x is minus infinity to here, that would be a good domain to make it 1 to 1. If you said x is between here and here, that also would be fine for a domain to make it 1 to 1. Or if you said x is from here to infinity, that also would be fine. So you have 3 answers to consider.
What about the points where it intersects the x-axis on the negative side and the x-axis on the positive side?
Here
Here all the way
to here. Let me think. No, the here to here wouldn't do, because, like, for example, here the height is 1, and then here the height is also 1.
No, I don't mean including that part, I mean completely removing that.
You mean cut out the centerpiece?
Yeah. Not the red. I mean...
Which color do you want me to cut out?
It's not the color. It's
Oh.
the moment the yellow touches the x-axis.
Here.
That point right there.
Yes.
And then to the opposite side of the graph, on the green,
Ah,
Yeah, do that.
You can try.
it's slowly increasing.
very good. Now we have 4 answers to consider.
Would that be practical?
Oh yeah, no, they're very easy to find, so it's just how you stitch them together. I suppose I don't want to go, okay, technically speaking there's an infinite number of answers, so let's not go nuts, okay? If you got 3, you'd get full marks. Anything more than that, I hope you had extra time in the exam or something, okay? Right, so let's look at how we can find the tree here. Well, this first point here, how could I find this point? Any ideas?
Which one?
What's special about this place here?
Turning point.
Yeah, very good. It's a turning point. And how do I find the turning point? Yeah, 3x squared plus 12x plus 8 equals 0. So mod 53, what are the 2 answers here? Come on, don't just sit there, Curdy. You were doing so well earlier today. Now you're getting relaxed. Come on. Oh, ugly answers. Give me those.
Wait, wouldn't it be
Did I get differentiate that correctly?
minus 4 for 3 and
3, 12, 8. Is everybody getting ugly answers? Okay, ugly's bad. All right, what's the first one? Okay, so I've made a typo in the question, but we'll still go ahead. What was your first answer? Minus 0.85, and then the second answer, minus 3.15. Okay. So since that answer is smaller, we'll call that one the A, which I'll mark there, and this one I'll call the B. I'll just mark it there. Okay, so what's one possible answer for the domain? Yeah, minus infinity to A. Okay, what's a second possible answer? Or A, yeah, to B. And then what's a third possible answer? B to infinity. And let's go with Brendan's fourth answer as well. Oh no, but we have to find where it crosses the x-axis, don't we? So that's mode 54.
so that's basically when x is 0 after.
X is 0, yes, but you want I want the first and the last. I want to do that one. minus 2, minus 4. So here, this point here, if you wanted to know, is minus 4. That's 0. And I know the graph is messed up. Minus 2 should be there, so 0. So yeah, a fourth one would be minus infinity to minus... By the way, don't need to do this fourth one. Minus infinity to minus 4 and 0 to infinity. Of course, there's many, many others. You're only really expected to get these 3. Say again?
If you write minus 10 to minus 5 and then minus 5 to minus
Yeah, that's what I was saying earlier. There's actually an infinite number of answers. So, no, that's not what I want for the exam. But that's how you can make infinite number of answers. You could do like minus 20 to minus 10, minus 10 to minus 5, minus 5 to minus 4.9.
Pretty much impossible to do this wrong.
No, I'm saying don't do that. That's not what I want in the exam. I want it like this. Because they might stick in the word maximal, like as in make the domain as big as you can. So you really want to try and make it as big as you can. Okay. I possibly now think that there's a typo in some of these ones because, you know, I usually make the quadratics have nice answers. So let's do... let's do a cosine one. Let's do 2c. Okay. All right. So we definitely know cosine repeats itself. It's going to be many to 1. Cosine, do we start at the top, the middle, or the bottom? The top. And then what happens? It goes down like this, and then remember cosine will be an even function, so it's the same on the other side. So this is where you can clearly see the infinite number of answers. But what would be our first possible answer? Well, if I was to start here, how far could I go to make this 1 to 1? So tell me when I would need to stop. Yeah. So that's one possible domain. But likewise, of course, this could be another domain. And this one could be another domain. So all of these are possible answers, okay? I'll just find the yellow one here because they're all basically the same. You just move along 180 degrees, it looks like. So let's find the first one here. What's the value of the angle here? 0. And what about here? In radians, what would this be? Pi. So if you want it to be 1 to 1, you need your angle to be between 0 and pi.
Wait, is it pi?
Isn't it? Yeah, it is. That's pi, and here is 2 pi.
Even if that does not apply.
No, sorry. This is not the graph for this. This is just plain old cosine.
Oh,
Okay? This is just regular cos. Okay. So for cos, you need the angle to be between 0 and pi to make it 1 to 1. Got it? Yes? So if I apply this knowledge to my function now, that means I need 7x plus 5 pi to be between 0 and pi. Looks familiar? Maybe you've seen this in semester 1, the double inequality. So what do we do first? Something. Take 5 pi. No, not this way. Take 5 pi from everything. And then to finish. And there you go. X must be between minus 5/7 pi and minus 4/7 pi. There is a domain that will make it 1 to 1. So if I just take this calculator here, let me just check that next cubic one. 3, this is 2D. All right, okay, I think in question 2, all the cubics are broken. So in number 2, you can leave the cubics for the moment until I fix them, but the rest look okay. Right, so what do I need? The most important question in this worksheet is number 3. And the reason I'm telling you it's the most important, Abanoub, number 3 is the most important because they have asked this question every year for the last 6 years. Right? Number 3 has been asked every year for the last 6 years. So there is a very good chance that you will see it in the exam. And if you see it in the exam, it should be easy marks for you because there's not too much algebra in it. You're just doing a little bit of rearranging. So I would recommend you'd want to do at least one of each type in number 3. So like for example, A, B, C, H, J, and P. One of each type of function, okay? And in number 1 and 2, you can just do the first 5, or any 5, okay? So 5, 5, and then one of each type in number 3. So you can start that now. Oh, you have the worksheets, okay. Let me make a note. I need to fix my cubics. And then my quadratic velocity ends. So Dave, you said you were causing any problems with Brandon.
He wasn't.
Was he?
It was me causing the problem.
Oh, how out of character for you, Brendan.
I was yawning.
Yeah, you keep yawning.